Hey, Econ students, Mr. McGrain here, and we are going to do a really speedy walkthrough of the 4 steps to calculating both absolute and comparative advantage. And then in part 2 of this video, we will look at a specific problem and see how comparative advantage is what sets us up for a trade analysis in a moment. So, 4 steps to calculating your advantages. Step 1 is you need to determine whether you are looking at an input problem or an output problem. In an input problem, you are going to be given the number of resources that are used in production. So we can see here that this chart represents an input problem because it is giving us the number of hours that it takes Nick and Jessica to produce. So it takes Nick 1 hour. That's not that he produces 1 pizza. It takes him 1 hour to produce pizza. So we call that an input problem. On the other side, we have an output problem. And an output problem gives the total level of production or the total level of output. So we can see over here that we're given the actual number of pizzas that Nick can make, or the actual amount of jewelry that Nick and Jessica can make. Step 2 is to use that input and output problem to help us identify our advantages. In an input problem, absolute advantage is the ability to produce using fewer resources. So we're looking for the lowest amount of resources needed. So we come up here and we say, who has the absolute advantage in the production of pizza? Who uses fewer resources to produce pizza? And the answer is that Nick's 1 hour for pizza production is less than Jessica's 2 hours for pizza production. For an output problem, you're looking for the ability to produce more of a given product. So over here, we look at who can simply make more pizza. Nick can make more pizza, 8 pizzas, than Jessica can. So he has the absolute advantage in the production of pizza. Then we can do the same thing for jewelry on both sides. On an input problem, who uses fewer resources, in this case the resource being time, who uses less time to make jewelry? Nick. Who can make more jewelry? Also Nick. So even when the problem changes from an input to an output problem, right, input or output will not change who is more productive, but it does change how we calculate and identify that productivity level. Right. Step 3 is the most critical step in this problem, in this process. And this is the one you absolutely have to get right. You have to know how to calculate your opportunity costs. And so we'll start here with a reminder that an opportunity cost is what you give up when you make a choice, or in this case, when you produce one good instead of another. And so we need to figure out how much does each person give up to do one level of production. There is a difference between how you calculate your input problem and your output problem opportunity costs. In an input problem, we're going to use the concept of IOU. Input problem, you do the opposite good under on the fraction. So we're going to make a fraction here and we're going to put the opposite good under. For an output problem, we're going to do the opposite good over. So output, we're going to say O, opposite good over. So in an output problem, just to give you that output, opposite over. So let's start on the input problem side. So we want to figure out how much it costs Nick to make pizza. How much does it cost Nick to make 1 pizza? So for input, we're going to say opposite good under. So we're going to say 1 pizza, this good, and then on the bottom of the fraction, we're going to put how long it takes him to make jewelry, right? So 1 hour on pizza divided by 2 hours on jewelry gives us an answer of 1/2 of a unit of jewelry in order to make pizza. So Nick gives up 1/2 of a jewelry when he makes pizza. For jewelry, we then do the opposite. So we say 2 hours on jewelry divided by, right, opposite good goes on the underside of the fraction, divided by 1 hour on pizza gives us 2 pizzas for every 1 jewelry he makes, right? So this is saying it costs Nick. If Nick makes jewelry, if he spends 2 hours making jewelry, then he could have made 2 pizzas. We do the same thing for Jessica, right? We take 2 hours, and I'm just going to start the shorthand here. 2 pizzas divided by 8 jewelry means that every pizza costs her 1/4 of a jewelry. And then the opposite over here, 8 jewelry divided by 2 pizzas gives us 4 pizzas per jewelry. So every time that Jessica makes a piece of jewelry, she could have made 4 pizzas. For the output problem, using the output chart, our fractions are all just going to be flipped over. So when we're looking at Nick, how much does it cost Nick to make pizza? We're going to say the opposite good goes on top. So jewelry goes on top of pizzas, right? So this is jewelry divided by pizza. So for Nick, that is 4 divided by 8, right? 4 jewelry divided by 8 pizzas equals 1/2 of a jewelry again. And then on this side, we do pizza divided by jewelry, and we'd get 8 pizzas divided by 4 jewelries, and we get a cost of 2 pizzas. Notice that our answers here are the same. 1/2 of a jewelry, 1/2 of a jewelry. 2 pizzas, 2 pizzas. But the fractions have to flip because we're looking at kind of reciprocal productive resources here. Right? So the cost to make 1 pizza, again, would be jewelry over pizza for Jessica. So 1 jewelry divided by 4 pizza gives you an answer of 1/4 of a jewelry. And then 4 jewelry divided by 1 pizza equals 4 pizzas given up per jewelry. Oh, I had this one backwards, sorry. 4 pizzas divided by 1 jewelry gives you 4 pizzas is the cost of making jewelry. The last step, of course, is to calculate your comparative advantages. And comparative advantage is going to create the space here for trade. So comparative advantage equals a lower opportunity cost to produce. So we simply need to go to this opportunity cost chart, and you're going to find the same answer on both sides. You want to look for who has the lower cost to produce. So who has the lower cost to produce pizza? Well, we go to the cost of making a pizza. Nick's cost is 1/2 of a jewelry. Jessica's cost is 1/4 of a jewelry. And we can say Jessica, because she only gives up 1/4 jewelry, Nick gives up 1/2 of a jewelry. So Jessica pays less to make pizza. Then we can do the same thing again with who has the lower cost to produce jewelry. And we come back up to the chart. Nick pays 2 pizzas. Jessica pays 4 pizzas. And we get that Nick, as he only gives up 2 pizzas, Jess gives up 4 pizzas. And you'll notice that this answer is going to be the same no matter where we look for it, right? The 1/4 versus 2, and then over here, the same 1/4 versus 2, right? So those are the 4 starting steps. I'm going to give you one more tip here really quickly before we depart. You have to remember it is impossible for one person to have the comparative advantage in both goods. They have to split their comparative advantages, right? Even though Nick was better at making both goods overall, Nick had the absolute advantage in both goods. Nick does not have the comparative advantage in both goods. It is impossible for Nick to have the comparative advantage in both goods. But if you can remember that step, it acts as a little quick self-check. But if you follow our other steps along the way, you will be successful all the way through. Good luck. Get some work on some practice problems done.